In this lesson, we're going to be talking about evidence acquisition. As a forensic investigator, you are going to be asked to acquire evidence as part of your investigation, and the evidence needs to be free of any question as to its authenticity, its integrity, or its accuracy. Now, you might think that you could just copy data off of a PC and you'd be acquiring evidence. The problem with that is that in the process of copying, you end up doing subtle changes to the data. So I'm going to do a little copy here, and I'm going to copy this file called encrypted.txt from my downloads directory to my documents directory. So I'm just going to paste it into place here. And now if I bring up properties on this file here, you can see the accessed date shows today. When you're doing an investigation, you want all of the metadata, including the created, modified, and accessed dates, to be accurate and reflective of the file that was actually on the file system. You may want to know when the person under investigation or the target of the investigation, when they actually accessed a particular file last. And if the evidence that you have acquired and present shows the access date when you did the copy, that's not a particularly good piece of evidence any longer. So you can't just do a simple copy that is provided by the operating system. What you need to be able to do is prevent any writes to the file system. And there are some ways of doing that. You can use what are called write blockers. A write blocker is something that prevents the write command from actually getting to the hard drive. There are a couple of different kinds of write blockers. One is a hardware write blocker, where it's done in hardware, not surprisingly, of course. And of course, the other one is a software write blocker. And you can get software write blockers that allow you to access hard drives in a way that prevents the writes from getting to the hard drive. So you have software write blockers. What that does is it protects you even in cases where you may be using safe utilities that wouldn't otherwise modify any of the data or the metadata. It would protect you from any accidental writes that may potentially damage the evidence that you are attempting to acquire. Now, normally, what you might do is use a Linux command called dd. Now, what dd does is it does a bitwise copy of anything that you may want to use as an input source. I could use an entire disk drive here. I could use a file. I could use an input device, because under Linux, basically everything is a file, no matter what you're actually doing with it. So I could, for example, here, I could do infile equals SDA1, which is my root of my hard drive, and I could spit that out to a file. So it would do a bitwise copy of my entire hard drive and put it into a file that I'm here calling root.dd. I could also call it root.raw, because what this effectively is a raw image. So I could take an entire hard drive and I could just write it out to a file, and at that point I've got all of the data that was on that hard drive in an image of a file. Now, what I could also do here is I could do something like write it out to a hard drive that's attached to the system. So I could take one partition here, which is SDA1, and write it out to another partition, which is SDB1. So I could take an entire hard drive and write it out to another hard drive bit by bit. That would be another way of doing it. Now, there are some potential problems with DD, and as a result of that, what you may want to do is use something called DCF-LDD, and it has the same characteristics as DD, except that I have the ability to generate hash files with DCF-LDD. So it operates the same way as DD does, but it has some additional capabilities for things like forensic purposes or other security purposes, like being able to potentially do a secure wipe of a hard drive is another potential usage of DCF-LDD. For our purposes, though, we would want to use DCF-LDD for its ability to copy files and hard drives and partitions, and to be able to generate validation data at the same time. Another important component to acquiring evidence is making sure that you have secured it. Once you have acquired the evidence, you want to make sure that you have documented the acquisition. You want to make sure you've documented exactly what it is that you have acquired, the manner in which you have acquired it, how the copy of the data has been stored, and any validation data like an MD5 hash or a SHA-1 hash, for example. You want to make sure you record all of that. And then finally, you want to make sure that you have secured both the original and the copy. It's important to make sure that you generate a good and valid and accurate copy of the original material, because you don't want to be working on the original material as you're doing your forensic examination, just in case something happens to it. If you're working on the original and you destroy it or make accidental changes, now you've completely invalidated the source material that you are using for the investigation, and so you put the investigation at risk. So that's different ways of doing evidence acquisition and some things you want to think about as you are going through the process of acquiring evidence.